Good morning, everybody, and thank you for joining us this morning. What we're going to do is go through a presentation by Dave here around options reports and optioneering. Just a bit of housekeeping as usual. Everybody's on mute. This has been recorded, so it'll be you'll be able to view it afterwards if you've got anything that you want to look up, and we'll make sure we get those links out. And there is a short survey at the end if you wouldn't mind filling that in. That really does help us. On the little box on the right hand side of your screen, if it's not there, there's a little orange box with a white arrow. If you click that, it'll pop out. There's a question section in there, and if you just type in those questions, they'll come through to me, and what I'll do is I'll ask Dave those questions at the end of the presentation. And that's pretty much it from me. So I'll turn you over to Dave. I'll just let you know we've been having a few issues with our webcams, so we're gonna turn them off so you get a full view of the presentation, but you'll be able to hear that come through for you. So I'll pass you over to Dave.
Thanks very much, Andy. I am Dave Bryden, and I'm going to be just turning my webcam off now, just so we don't distract from the presentation. And what we're going to talk about today are options reports. And these are options for reducing water costs, reducing trade effluent costs, and options for improving effluent management. And the concept of an options report applies to any sort of premises, whether that's a commercial premises, a leisure premises, a manufacturing site, a chemical plant, or an oil refinery, anything like that. And quite a lot of the examples I've got in here are about trade effluent, because options reports are a very powerful tool that you can use when looking at trade effluent. But also I've got examples in there where I've applied the options report concept to commercial premises and water consumption in those premises as well. So if we go to the next slide, I'm going to talk about options and optioneering. I've got optioneering in italics there. It's a word which is used quite frequently in the water industry. It's a little bit more common now in the wider industry than it used to be. I'm just going to define exactly what it means. And I'm going to define what I mean by options and the level of detail that options reports go into. And then I'm going to talk a little bit more about the actual structure of what an options report and optioneering exercise is. And I've said in the contents page there for identifying effluent options, as I said in the introduction, it applies to anything really. So I'll go through the stages of optioneering, what the benefits of it are, and I'll talk about some case studies as well. As I go through the presentation, I'll introduce a few case studies as I'm talking. So what is optioneering? There are a couple of definitions on the screen there, and as I said, it's a word which is sort of artificially constructed. I joined the water industry 24 years ago, and it was just becoming widely used then. I work in lots of different industries with clients in commercial and leisure and manufacturing, and sometimes I use the word optioneering and they've never heard of it, or they don't quite know what it means. So I've got a couple of definitions up there which have come from other sources, and I've circled some of the relevant parts of those definitions. So if we look at the top definition, you can see that I circle confident course of action. Optioneering is about making the right decisions, and it's about giving you a very sound basis for making those decisions. So one of the definitions of optioneering is it gives you that sound footing on which you can make a good quality decision, and you can be confident that you've made the right decision. The bit underneath that says demonstration of due process. This is really important for a number of reasons. If we look at it from a fairly simplistic point of view, any decision can be challenged, and particularly if you're making any sort of engineering or investment decision, or a decision which could potentially change a manufacturing site or change how a commercial premises works, you need to be able to justify that decision. That could be justifying it from the point of view of investment, or if things go wrong or mistakes are made, you need to be able to demonstrate exactly why you made that decision and what the basis of that decision was. So that's one definition of optioneering. If we look at the definition underneath, the bit I've got circled there is about choosing the best option, or the most appropriate option, or the most suitable option. Sometimes I go around clients' premises and I see equipment, for example, that's been installed and it probably wasn't the best solution for that site. And that is quite often because the client didn't go through any sort of systematic optioneering process. If they had done, they could have come up with a better solution. I'm going to mention something now, which is about the sort of legal aspects of this. I, in the past, have occasionally worked as an expert witness in litigation cases. And every case that I've worked on has come about because an optioneering process had not been used to decide on some sort of investment decision. And when the decision came to fruition, it was discovered that it probably wasn't the best decision for the client, and litigation ensued between the client and a supplier or a consultant or another party. Now, that's not a scare tactic to say that you definitely have to have an optioneering report or an options report to avoid litigation. That's not correct. But it's all about justifying the decision. And the conclusions that were reached in all of the litigation cases I've been involved in as an expert witness were all about why weren't options considered more thoroughly during the optioneering stage of the programme. So optioneering reports and options reports cover a number of things, but it's all about, as I say at the bottom on that slide, it's about identifying the appropriate option or what the options are, because quite often there are more than one, and then selecting the one that's most suitable for a particular project. It's also about avoiding mistakes as well. And as I go through the presentation, I'll talk about some situations I've come across where mistakes have been made during this phase of a project and that they could have been avoided with a little bit more thought. So why do we need to optioneer? So again, this slide talks about effluent treatment, but the whole concept applies to anything. So if we think about effluent treatment to start off with, investment needs to be allocated wisely. Investment decisions about effluent treatment can often be expensive. If you're looking at a water supply side of things, for example, say you're retrofitting taps and wash basins and toilet systems in a big commercial premises, you need to make sure you're making the right decision. So optioneering helps you to allocate that investment wisely in the right areas at the right time as well. Your solution clearly must meet the needs. If we go back to the legal cases I worked on, the solutions that were put in certainly didn't meet the needs of the project. And that was partly a failure of project management. And that failure came about through lack of optioneering or lack of sufficient optioneering. So you need to go through the options to make sure that the solution you're getting is going to do exactly what you need it to do. Not what you want it to do necessarily. Sometimes what project managers want things to do isn't necessarily what needs to happen. So you need to make sure you've got that impartial, systematic view of looking at what the solution is and does it do what it's supposed to do. The bottom bullet point might sound a little bit odd. The decision needs to be appropriate for the right duration. Sometimes a temporary solution or a temporary option might be the ideal thing for a project. I've recently done a project it was in the water industry. It was on large scale disinfection. And there were two competing options. One was to put in a permanent disinfection plant, and the other one was to put in a temporary plant. And when we considered the options in detail, what we found was that actually the temporary plant would be the best option. There was no point putting in a permanent plant, even though that some people favoured doing it. The temporary option was by far the better one. So when you consider options, you need to consider the timescale over which that option or that solution will be needed. Do you need to hire equipment in? Do you need to put something in temporarily? Is there something that you could do quickly which would be much better and much more appropriate than putting in a permanent solution? So that's what I mean by the decision needs to be appropriate for the correct duration. So this is all about making the right choices, but in a structured and auditable way. What I want to talk about now is the level of detail that options reports go into. These are options, these are conceptual options. An options report doesn't give you the final answer in one fell swoop. What an options report does is it essentially presents you with the choices that you've got, and it does that in a level of detail which lets you know roughly what you're looking at, what sort of investment you're looking at. If you need to buy equipment, what are the choices for buying equipment? You can then use the results of an options report to refine the options and choose the best solution. So we'll look at that in a little bit more detail. So if we think about a project management process, let's say you are going to install some equipment. So let's say you run a big office complex which has several thousand people in it. I've worked in a number of offices like that. Let's say you want to retrofit taps and toilet systems and urinal controls and things like that. There will be a number of options for doing that. You start off with the first stage, which is concept screening. And this is all about defining exactly what you want to do and defining what the options are. And that stage is where the options report comes in. So this is defining what you want to do. So for example, I want to replace all of my taps and toilet systems. What are the options for doing that? What are the latest developments in that sort of equipment? And what does it cost? Where are the suppliers? Can they supply everything we need to supply when we need it done? And that's what all goes into the options report. The options report in that example might also consider things such as, do we need to have a water education awareness program within the factory or within the premises? Would that help to reduce water consumption? And might that reduce the investment that we need to have in the future? So that's what an options report covers. Options reports sit firmly in the concept screening stage. Once an options report's been completed, it goes into the next stage, which would be detailed design. So sticking with the example about a large-scale retrofit in a commercial premises, for example, the output of the options report would be taken and they would be turned into something much more tangible. So one or two options might be picked. You would do all the detailed work on that to really refine the costs and the program. And then you would pick the final answer, which goes into technical design. So that's when you get the suppliers involved and you do the really detailed analysis of costs. And that blends into stage 4, which is the as-built design. So that is what you actually construct or what you actually install or what you actually do. So concept screening sits very firmly in the first stage of that. And this is what drives all of the other stages of the program. And you would hope by the time you get to stage 4, or even by the time you get to stage 2, you've identified what the most appropriate options are. So you don't get to stage 4 and then realise actually there was a better option which you could have done several months earlier. So this gives you a level of detail which is sufficient to understand what you perhaps need to buy, do, how much it would cost, what the suppliers are, and you get what I've referred to there as a budget cost. Sometimes I refer to it as an outline cost. So typically that would be accurate to maybe plus or minus 30%. It gives you sufficient information to set budget and understand what the likely investment is going to be. So that's the level of detail that options reports tend to provide. So if we look at a bit more detail about what the stages of an options report are, and that there are a number of stages, and as with any project management scheme or any project of any type, it lives or dies according to the communication and the data and how you handle that and how you use that to make decisions. And it's also about the collective knowledge of the people who are working on the options report as well. It's always worth doing some sort of brainstorm to come up with options which might not necessarily have been thought of. And it's always worth doing that to make sure that you don't miss out any key things which could be really important. So if we look at the stages of an option report, if we start in the top left-hand corner with data analysis, regardless of what you're doing, whether it's a water retrofit, effluent treatment, effluent management, whatever it is, the first stage is to gather your data. Now, that could be numerical data about water consumption or effluent production. It could be about number of members of staff, what your budget's likely to be, what your timescales are. And in good project management practice, the first thing you do is set out your scope. So you set and you agree what the basis of the options is. So if we think of effluent treatment, that could be what's the maximum volume of effluent I need to treat? What's the composition of it? What are the regulatory concerns? Are there any timescales I need to meet? The other thing that could come out of that stage as well with data analysis is identifying any quick wins. So that might be, as you're going through the data, you might realise that actually there was something, or there is something really quick I could do, which removes part of the problem. And that might then affect the level of investment and level of involvement that you need downstream in the programme. So data analysis is always the first part of this. That then moves into the top right-hand corner, which is option identification. So this is partly the result of the brainstorming that I mentioned before and the collective experience of the people doing the options report. This is where you identify all the appropriate solutions. So if we stick with effluent treatment for a while, because it lends itself quite nicely to this sort of options report. Let's say you've got an effluent treatment problem and there are a number of different ways you could treat that. This is where you would identify what those treatment solutions might be. So for example, it might be a biological solution, or it might be a physical solution, it might be chemical. So you identify all of those solutions. You do an outline specification. So that would give you the outline footprint of what the solutions are, the outline costs, as I mentioned before, say the plus or minus 30%, who the suppliers are, and whether those suppliers could supply the equipment in the lead times that you need. And this effectively becomes, for want of a better term, it's almost like a shopping list or a short list of options that you've identified. And then you move into the sort of outline costing bit. So I jumped the gun a little bit in the previous comments. Once you've done the option identification, you can then start looking at the purchase costs, the installation costs, an initial cost benefit analysis. So it could be that some of the options, while they could do the job, might be very expensive and it might not be cost effective. I'll give you a very quick example of that. A project I've worked on recently in the water industry was looking at ozone to clean a specific type of filtration process. And while it would be very, very effective, and probably the most effective solution for that particular project, it was very, very, very expensive to buy and to operate and to maintain. So it was an option, but it was discounted at the initial cost benefit analysis stage. It was just considered to be too expensive. It didn't fit the timescales or the budget or the operability needs. So as you're going through these stages, you always keep in mind that some of the options might be removed or discounted for various reasons as you're going through. Now, once you've done the outline costing, we slightly confusingly jump across to the left-hand side where it says solution identification. You've picked the options. Some of those options, as you're going through, will clearly be more appropriate or more suitable than others. So if we think about the ozone example I've just given, that was discounted. Other options for cleaning the water treatment process were considered to be more suitable based on past experience. Some of them were relatively novel, but it was clear that they were worth looking at in more detail. So you select the best options or option. You refine the design and the cost a little bit. Bear in mind that this is only supposed to give you outline estimates of size and footprint and cost. So you might refine it by doing a little bit more work on the footprint or working out what the costs might be and working out a little bit more about the design. So once you've done all of that, you then move into the bottom part, which is the important bit, which is about reporting about it. You tie all this up into an auditable report. And this is effectively your summary of why you made these decisions. So if we go back to the office retrofit, in there, that would say, this is why we've done this. This is why we have made these decisions. This is why we think the investment is likely to be this, because we got these costs from these suppliers. So this is the reporting bit, is the key thing. This is the deliverable, and this shows the audit trail. So there's the stages. They're the stages of the optioneering process. And as I said, this is really, really important for defining and producing this systematic, structured method of looking at all the options. So let's look at something specific, something about trade effluent. for those who aren't familiar with trade effluent, if you're a manufacturing company or even if you're a commercial premises and you discharge anything to sewer, which is considered to be trade effluent or as a result of manufacturing, then you need a permit to do that from the water company. You can't discharge that without a permit, and that is called trade effluent. So let's look at this graphic here. This is a graphic of a chemical plant. So let's say that you are a chemical manufacturer, and let's say that you produce trade effluent. And let's say you want to look at options for treating that trade effluent. So what you would start off doing is considering all the options. Where does the effluent come from? So it could be lost product. Product gets spilled, it could end up in the drains. It could be boiler blowdown. It could be surface water that goes into the trade effluent sewers. Could be from vessel washdowns and things like that. And how this process works in manufacturing areas is, when it's allowable, thinking about lockdown restrictions, is going onto site and physically looking at all of these things, because there could be options which are very simple to implement. If you look at the graphic in the bottom right-hand corner, a production line, food manufacturing site, there could be clean-in-place solutions. There could be water in the product, there undoubtedly will. There could be water going to drain. So if I give you a couple of very quick case studies here, if I think about the chemical manufacturing one, I was involved in a project last year where a client put something down the drain, which was particularly noxious. It was something which they had a trade effluent consent for, but it really increased the composition of their trade effluent, which increased their costs. And they were looking at treatment processes for that. Having done an audit, having done a walk around of the site and talked to the engineering managers and the maintenance managers on site, it became clear that there were options for preventing that material from going down the drain. And they actually put them in place. They realigned their drainage and they managed to exclude this stuff from the effluent. So that really saved them a problem. It saved them money, and it's improved their compliance with their trade effluent consent. They still needed a treatment plant, but that treatment plant then became smaller because this particular contaminant had been removed, and it was a different process. So just by looking at what I call potentially the quick win options, that client avoided unnecessary expenditure. If we look at the food manufacturing plant in the bottom right-hand corner, one case study about that, I worked with a meat processing company, and this is going to be mentioned a bit later on in the presentation as well, who had various options for treating their effluent, and they were quite concerned about the potential cost of doing that. And again, I went round, did a factory audit and came up with some options which effectively sorted the problem out. It meant that they didn't actually need to put in a treatment plant. They could do everything they needed to do just by changing the way the factory operated. And that's quite a glib statement. I've worked in lots of manufacturing companies and done projects in lots of manufacturing areas. And I know that it's not necessarily straightforward to change behaviours in factories, but it's always an option. It's always part of the options for trade effluent, and it can have very significant benefits. So a really important part of the options report for trade effluent is looking at the quicker wins and maybe the options which don't necessarily need large investment, but which could have significant benefits. So if we look at what these options could be, so let's say it's a manufacturing project and you want to have a look at options for reducing trade effluent. I've got a fairly lengthy list of things there that you would look at, which builds on the previous slide. So this would involve looking at all of these things, building up a picture, understanding exactly where all the effluent comes from, where all the water goes, what's it used for, and looking at how things could be changed. So for example, if you've got surface water that goes to a sewer, Does it need to go to the sewer? Is that just increasing your trade effluent volume? Should that be going to a separate sewer or maybe in the water course? Do you use water for washdowns? And I've got a couple of slides coming up about that in a minute. If you do you need to do it? One thing which I often wish I'd done was many years ago, a former colleague of mine went into a meeting with a client in the food industry armed with a brush and dustpan, and he presented it to them in a meeting and said, you don't need to wash down your factory floor because all you're doing is using lots of water and washing lots of solids down the drain. You need to be sweeping it. And the simple act of sweeping material off the floor rather than washing it down the drain saved that client a huge amount of money and saved them a lot of problems with effluent compliance. And that was the best option for their site. So there were other things on there. Can you reduce water pressure? Could you optimize cooling towers? Could you recycle and reuse effluent? Do you have steam leaks? And I've got a photograph of a steam leak coming up in a minute. Do you have submetering? Do you actually know where your problem areas are? So these are all what I call minimization options. So if you have a look at the graph on the right-hand side, I briefly mentioned this beforehand. This was the client in the meat processing company, and the bars show the average daily consumption over the course of several months. And at the point where the red line is, that was where I went in and did an audit. And the client was very concerned. They thought they were going to have to buy an effluent treatment plant. I went in, and what I noticed was there were lots of ways in which they could improve how the factory operated. So a couple of months after the audit, they implemented some of these measures. You'll see on the right-hand side, possibly where my cursor is, there was a bit of a spike there. That's when they did a deep clean of the factory to really clean it down and get rid of all the stuff that was in the drains. And you can see that after that, the water consumption in the factory plummeted. And the overall reduction in water costs was actually 36%. And that 36% reduction came about simply from changing the way the factory operated. So no effluent treatment equipment was needed. And the cost of doing that, other than the cost of the audit, was minimal. It was changing some plumbing within the factory. It was removing pressure washers. It was buying brushes and dustpans. It was putting flow restrictors in and reducing the water pressure. So that had a really significant benefit for the customer. It sorted out the problems for them. So in that case, the best option for that customer was water minimization, and that solved their problem. But a look at another couple of trade effluent examples. It might get to the point where you do need to put some sort of treatment in for trade effluent. So you need to look at things like removing what the larger contamination is. The larger contamination could range from anything from large pieces of grit to mobile phones. I've seen all of that sort of stuff in trade effluent. And then you look at preliminary and primary treatment to remove solids, removal of dissolved contamination, and then looking at whether there are any opportunities to recycle the effluent. So if we look at the photograph in the bottom right-hand corner with the 5 jars with the black lids, the right-hand jar is the untreated effluent from a client in the chemical industry. And as you can see, it's a dark, well, sort of beigey brown colour. It was quite viscous stuff. There was a lot of solids in there. On the right-hand side, that was the treated effluent. And you can see that the COD, the chemical oxygen demand, which is a measure of the gross contamination, the untreated effluent was about 8,000 milligrams per litre. So that's 8,000 parts per million. If you look at the jar on the right-hand side, the COD of that was actually less than 50 milligrams per litre. And that was from a pilot trial of some treatment equipment. And what this enabled the client to do, they subsequently built a plant, was to recycle the treated effluent within their site. And this was the best option for them. It allowed them to comply with their trade effluent consent, which had been tightened and which was causing them problems. And it reduced water costs because it meant because they were recycling effluent, so they didn't have to buy water. and it reduced the load on the sewage works, so the local water company were very happy as well. So the option that came out of that was that, removing 99.9% of the COD and everything else that was in there was really beneficial for the client. If you look at the photograph with the conical flasks on the right-hand side, this was a slightly different one. The flask on the left-hand side, you can see, is a sort of bluey black, purpley colour. The problem here wasn't actually the COD, the problem was actually the colour. You can't really see in the photograph, but in some circumstances that effluent was actually a particularly bright and vivid purple colour. And when that effluent ended up at the local sewage works, it wasn't removed by the sewage works, it tended to pass all the way through. So even though some of the COD was removed, the effluent leaving the sewage works discharged to the river was occasionally purple. So the water company instructed the trader to do something about it. And we went through an optioneering exercise, looked at a number of different processes, some of which were quite novel. There was no way of excluding the purple dye from the effluent. It was always going to end up in there. There was no real way of avoiding that. So there was no minimisation solutions. Trials were done, and as you can see on the right-hand side, that effluent was almost perfectly clear. There's a slight tinge in it, but it's much more acceptable than the flask on the left-hand side. The spin-off benefit of that was there was a significant reduction in COD, which also reduced their cost, and it reduced solids as well. So just to summarise that slide, you've got two examples there where an optioneering exercise for manufacturing companies really solved the problem. And without going through those options, it's quite possible a client might have arrived at a different conclusion, but it wouldn't have been the right long-term conclusion for those clients. So if we move away from trade effluent and we move on to water consumption, put a couple of photographs here about water use, and these are from manufacturing areas, but this is not about effluent, this is about water management. So if we look at the left-hand photograph, ignoring the state of the equipment, which wasn't particularly good, circled within there is a steam leak. Steam leaks can be a number of things. They can be dangerous, depending on the temperature and pressure of the steam. They can be a real hazard. They can cause failure of tubes and pipes. So you can see that particular steam leak is jetting out of the rubber pipe, which could potentially have perished over time. It was making the floor wet, which is a health and safety hazard. It was also leaking steam from the hot water system. Hot water is more expensive than mains water, obviously, because you've got to heat it up and treat it. So the losses from steam leaks can be quite significant. And on this particular site, there were a lot of steam leaks. Look at the middle photograph. This comes from what was actually a commercial kitchen, and that steel trough there was used to effectively rinse lots of packing trays. So if you think of the plastic trays that you see in supermarkets that goods are delivered on, they went into that steel trough and they were washed before they were sent back to the suppliers. That copper tap, was dripping. You can see circled there. That had been dripping since time immemorial. When I went around this particular kitchen, everybody said, yes, it's always dripped, and we just left it. Now, that drip had been going on 24 hours a day, 7 days a week for many years, and that was a lot of water that had been lost. So the option that came out of that particular audit was, number one, stop the leak and improve the tap and valve arrangement on there to prevent that, and also to educate the staff, because they all knew it was happening, but nobody had ever really thought it was a problem. The cost of it wasn't visible. And what that client actually did was put a poster on the wall which said that if this tap drips like this for this length of time, it costs us this amount of money. And those posters actually worked very well. It was a nice visual reminder to the staff that they needed to look for leaks and drips. If we look at the photograph on the right-hand side, This was in a distribution warehouse, actually. And you can see there that the client there has actually done the right thing. They've got a hose pipe with a trigger spray on, and trigger sprays are always recommended so that they don't drip all the time. But fortunately, this one was dripping all the time, and it had just been put on the floor next to the floor drain. And again, that dripped and ran continuously. It always had done. And for the sake of just putting a new trigger spray or a new trigger gun on the end of the hose, they were actually wasting a huge amount of water. There was a double whammy here because they were buying the water from the mains, and it was actually dripping into the floor drain, and it was increasing their trade effluent costs volumetrically. And this wasn't the only example in this particular site of where there were leaks like this. So one of the options that comes out of water use is, are you using it sensibly? Is it being managed well? And in these cases, you can see it wasn't. So steam leaks, water leaks, dripping taps, water management within sites, they're all things that come out of the options reports. If we look at sort of water use in manufacturing areas, you could have leaks from equipment. Equipment needs to be cleaned. You could have steam leaks, like I'd mentioned. Floor cleaning is another one. As I was saying to Andy yesterday, we were talking about this. I had an example in a manufacturing company where the client had a set procedure for cleaning the tiled floors in the factory, and that involved using sachets of floor cleaner. And the cleaners were putting an entire sachet of floor cleaner into one bucket, using that to clean the floors. What that did was it made the floors extremely slippy, and that particular site had a very poor record for slips, trips and falls. So there was a health and safety issue caused by poor water use and poor water management. And this was another site where the recommendation from the options report was sweep the floors, use less detergent and use less water. And that actually sorted the problem out. So the optioneering process for this sort of situation, it looks systematically and in a structured way at all these opportunities for reducing water consumption and reducing water use and improving water management. If we think about the more not necessarily mundane aspects, but things like toilets, urinals, wash basins, things like that. Urinal flow controls are things which often come out of options reports. Typically, they should be either done on an infrared sensor or maybe flush every 20 minutes, but only when the office is actually occupied. I often see urinal flow controls which is flushed continuously because they're broken or they haven't been set up properly, and that can use a huge amount of water. The other part of this is there has been a move towards using waterless urinals. Now, on the one hand, you might think, yes, that reduces water consumption, it improves water management, but on the other hand, they can cause problems. And I had a client a couple of years ago who removed all of their ordinary urinals and replaced them with waterless urinals. Now, all of the sewage from their site went to an on-site sewage treatment works, a small package plant that was buried underground outside the site. The lack of water from the urinals meant that what reached the sewage works was less diluted than what it had been, and that caused problems at the sewage works. It actually meant the sewage works wasn't complying with its discharge consent to a local river. So what the client did was they actually took out all of their waterless urinals and put the water flushed one back in. So that was a failure of the optioneering process because the impact on the sewage treatment plant hadn't been considered during optioneering. If you look at cistern flushing, I did an audit in a very large office a couple of years ago where they had very, very new, very modern cisterns which only offered about 4 litres per flush, which isn't a great deal. A standard cistern might offer 6 litres, the older ones maybe 9 or even more. And what the maintenance manager told me was they had a rolling programme of taking out these low flush cisterns and putting in the 6 litre cisterns. And the reason was, without putting too fine a point on it, the 4 litre flush just wasn't enough. So people were flushing the toilets twice or 3 times sometimes. And that was using more water than what they thought it was going to use, obviously, but it was also putting more wear and tear on the flush mechanisms, which eventually broke. So every time one broke, it was actually cheaper to put in a higher flush system than replace these proprietary flush mechanisms. So again, that was a failure in the optioneering process to really understand the impact of this. And on the same site, they'd put in very water efficient taps with PIR sensors. Again, they didn't deliver a huge amount of water. So when people were using them, they were maybe operating the taps 3, 4, 5 times to wash their hands. And eventually the PIR sensors broke. So the client had a rolling program of removing those taps and putting in push taps. And then we have the classics of dripping taps, dripping showers, push taps, which operate for far too long. So most push taps, when you push them down, should operate for maybe 10 seconds. It's not unusual when you do this sort of audit to find taps which operate for a minute. So you're using 6 times more water than what you should be. And domestic water losses can be considerable. And again, one of the options which comes out of this quite frequently is talking to staff and doing water education strategies within office blocks to make sure that people understand exactly the impact of water use. So let's have a look at a little bit more detail about some case studies. So this was a client in the meat processing industry. This is a trade effluent example. They were failing their trade effluent consent, and they were very worried about it, and they thought they were going to be prosecuted. And their trade effluent costs were increasing. They were very busy. And they'd looked around for solutions to the problem, and they'd been told that effluent treatment might be an option. So this wasn't a particularly big company, but they'd been quoted between £20,000 and £55,000 for an effluent treatment plant. That isn't that expensive for an effluent treatment plant, but it is if you're a smallish company that employs maybe 15 or 20 people. So they were extremely concerned about this. This would be a very, very significant investment for them. I did an optioneering study on the site. I went round and noticed that a huge amount of solid material ended up on the floor, and it was pressure washed down the drains with high pressure washers. These were the sort of pressure washers that you see at car washes, the really, really powerful ones. And that was clearly the source of the contamination, but it was also using vast amounts of water when they didn't need to. So the option that came out of that report, the most appropriate option, was remove the pressure washers, put in low pressure hoses, again, sweep the floors. What the client found was that actually, if they could get the contamination, and effectively this was just waste meat, off the floor, it could actually be suitable for use by a local meat rendering company. So they took it off the floor, they put it into receptacles, the local meat rendering company came and took it away. So they actually got a little bit of income for something which had actually been causing them a cost. Overall, that reduced their trade effluent costs by 48%. It actually also removed their trade effluent compliance problem, because the stuff that was causing them a problem was no longer going down the drains. So they also avoided the £20,000 to £55,000 investment in an effluent treatment plant, which would have worked, but it just wasn't necessary. So the best option for this particular client was go through and do effluent and water minimisation. If we look at this one, this was a large secondary school with about 1,500 pupils in it. And I did an options report for water reduction measures, which identified a number of savings from improving the efficiency of shower heads, looking at toilet systems, taps, water use in general within the kitchens. So we think about that drip tray, which wasn't from this school, but they used similar things. And that identified that over the course of a year, they could save about 1,000 cubic meters of water. Now, the tariff that that school was on at that time had a price of roughly about £1 per cubic meter. It's more now, but at the time it was about £1. So that was roughly about £1,000 saving a year, which is actually quite a decent saving. And they didn't have to do a huge amount of work to make that saving, so the payback on it was actually quite good. What came out of it was we were also doing a trial of AMR, automated meter reading equipment at the time. And the AMR loggers noticed that there was quite a lot of water use overnight and on weekends when there shouldn't really have been a lot. Excuse me. And that was isolated to a number of things. It was isolated to how the boilers operated. It was urinal flow controls. There were various flushing mechanisms on the heating system. But also on a weekend, local football teams used to come in and use the facilities to play local football non-league games on the school's pitches. And it was about the shower use and the water use on those periods outside the normal school hours. And what came out of the AMR study was that making some changes in overnight water use and regulating the weekend use, that could save about another £1,400 a year in reducing that usage. I've said overnight use there in the circle, it was actually the overnight and weekend use. So in total, that came to about £2,400 a year just by looking at simple options for changing water use. This one I've actually already mentioned, so I'll skim through this one. So this was the office which had been fitted out with very, very water efficient fixtures and fittings. And what drove the need for the options report was that the building manager was comparing the water consumption per person with what she considered to be benchmarks for excellent use, and they weren't meeting them. And what she wanted to achieve was a use of 25 litres per person per day. Now that is very, very low for an office. It's typically maybe about 50. 25 is exceptionally low. When I looked at the data, they were actually using about 37 or 38 litres per person per day, which is very good, but it's not 25. And I did an audit, looked at the options for how to achieve the 25 litres per person per day. And the conclusion I came to was that 25 litres per person per day for that site was not attainable. Given the number of people on the site, and there was something like 3,500, and how many times the toilets were used each day, excuse me, and taps and the kitchens and canteens, it just wasn't achievable. That target hadn't been set wisely during the optioneering phase. So, as I said earlier on, I went through, I did the options report, and what came out of this were toilet systems, the infrared sensors on the taps, and also the behaviour. And it was partly due to the inappropriate choice of the solution. During the optioneering phase of this project, what should have come out of this was, how would the technology be used? Is this the right solution for this particular site? Nobody had really looked at the patterns of use, and nobody had really looked at shifts or weekend working or overnight working. There was a large call centre in this site as well. So the client had gone all out for the most water efficient equipment they could get without really thinking about how it would be used. And that was what caused them the problems. So the options were to go through and retrofit more appropriate equipment, and also actually to revise their targets. While the 25 litres per head per person was admirable, it just wasn't achievable on this site. And stabilising the use at somewhere between 35 and 40 litres per head was what they should have been aiming for, which is what they ultimately did. So I'm just about coming to the end now. I just wanted to summarise really what options reports are again, and what they do, and what their intention is. It's about producing this systematic, structured method of identifying what your options are for water consumption reduction or for trade effluent minimisation. And it's all about establishing what the basis is for any decisions that you make, and making sure that you've accounted for all the possible options that are appropriate for your site. So have you thought about all of the treatment options for your trade effluent? have you really thought about how taps and toilets will be used in the shift patterns of your office, for example? If you run a factory, have you really thought about how you clean the floors, etc.? And it's about looking at what I call the non-investment opportunities or the quick wins, so changing operating practices, or the investment opportunities, which is installing equipment or treatment plant. So the options reports give you this structured, systematic way of looking at all the options. And it's applicable to anything. Conceptually, water use, trade effluent, any premises, whether that's leisure, commercial, manufacturing, oil refineries. I've done that in all of those different types of premises and more. It can just be a standalone piece of work. If you think about the slide I showed previously, which had the 4 or 5 stages on, it could be that you just want the options. You just want to understand in what in the future you might have to do and how much it's going to cost. It could be that your thoughts are a little bit more advanced than that, and that what you actually want to do is understand the options and then move straight away into the solution identification and detailed design phases. But it can be used as a standalone piece of work or as the basis for significant investment decisions or significant changes in maybe operating strategy. But the really important point is number 4. It ensures that you've been diligent and that the decisions you've made have been rigorously assessed and that they are high quality decisions. Going back to the legal work I've been involved in the past, and as I said, this isn't necessarily trying to say that you have to do this to avoid litigation, because I just want to reinforce that's not true. They've all come about because the decisions weren't rigorous. The options weren't looked at diligently, and the decisions they came to weren't high quality. There were other things that they could have done. And when that comes to a legal arena and you're being questioned about it, it's not surprising how quickly a decision which appears to be robust falls apart. So don't get scared about that. The point I'm trying to make is options reports are about making sure you've got that sound basis for justifying what your decision actually is and why you made it. So if in the future somebody comes to you and says, why did you make this decision? You can produce a really structured, auditable way or auditable solution, a good audit trail for doing this, which is what the box at the bottom says, really. It's systematic, it's structured, it's an auditable way of looking at what your options are. And we do this, like I say, in all sorts of different establishments, commercial, industrial, manufacturing, swimming pools, oil refineries, food manufacturing sites, pharmaceutical sites, warehouses, distribution depots. It's something that's applicable to everything. It ties in very nicely with project management procedures as well, making sure that you've really assessed all the different options. And it also ties in well with what I mentioned earlier, which is sort of brainstorming new ideas and new ways of working, rather than just, for example, for effluent treatment, putting in an end of pipe solution. Is there actually something different you could do further upstream in the factory which would solve the problem and avoid unnecessary expenditure? So that's effectively it from me. That's what options reports are. That's how they work. It's the level of detail they go into and what you can effectively expect from them. So thank you for your time. And if there are any questions, we could go through them now.
Brilliant. Thanks very much for that, Dave. I'm just going to put my camera back on. I don't know if, Dave, you want to put yours back on as well, just so people can kind of see us. Yeah, no, thanks very much, Dave. That was really interesting. I think, like, sort of going through that, there was a couple of kind of takeaways that I got from that, just like at a very kind of high level. And I think some of them is kind of like, you know, you're right, it's about being auditable, but it also probably forms your business case if you're looking for investment from your kind of C-suite, and you know what you need to do, you want to get it there. Then an options report gives you that really auditable and sort of quantified sort of options to get you to, you know, to be able to take that to your management team to say, this is what I've
Yes,
done, this is what we need to do, and it's kind of almost a well, we're around Christmas time, aren't we? A nice wrapped up parcel of kind of this is the information you're required to make that informed decision. So I think
it is.
it's important from that point of view. I think the other thing that I got from it as well was just that oddly enough, you can kind of go down a route of trying to be really, really water efficient for all of the right reasons. And you can take your staff on that journey with you as well. But actually, if you kind of push it just that bit too far, you can almost create the opposite behaviour to what you're trying to
Yeah,
get through this kind of repeat use of the facility, because it's not delivering what it should deliver as a solution.
exactly. And it's all, exactly right, Andy. And it's all about setting the targets and the key performance indicators as well. So in the example I gave there, the target the building manager had of 25 litres per head per day was admirable, but it was just never going to be achievable. It was never going to be attainable. And what you found was that actually, given the equipment they had and the usage patterns they had in that building, the pattern they used to had of 37, 38 litres per head per day was probably the natural average of what they were going to get. And compared to other similar establishments, that actually compared very well. It came out as very good on the benchmarks. And when you looked at the size of the place and how it was used, it would have been difficult to get down any lower than 38 litres per head per day. The other key thing, which I didn't mention about that particular site, was they also had a rainwater harvesting system, and they had a grey water treatment system in the basement of the building. The roof of the building was a very odd design, and it didn't capture anywhere near as much rainwater as we thought. A lot of it actually just ran down the side of the building, and so that didn't really do what it was supposed to. The grey water harvesting system was supposed to take effluent from the toilets and showers and things on site and turn that into reusable water they could use to flush the toilets with. The engineering manager on the site found it very problematic to operate. It only actually ran for 6 months and he turned it off. And what he then did was use the tank that it was in to store extra rainwater. So again, they'd had the right intention to reuse and recycle water, but it hadn't really put the right thought into how it would be used and how it would be operated.
Yeah.
And it was very, very problematic. It wasn't the right option for that particular site. So it was actually quite a good case study of how they'd overreached themselves. The targets they'd set just weren't really achievable.
Yeah, I think last point from me was I think as well just the quick wins that are there from a processing point of view, because you're absolutely right. If you go into a particular manufacturing place and they have a set way of doing things that have probably worked quite well for them for a number of years and allow them to be efficient as everybody tries to be nowadays. But actually having that fresh set of eyes from looking at it as a point of view of efficiency around water and utility, I guess, when you talk about kind of like steam leaks and things of that nature, and actually the idea that they could just scrape that up and put it in bin bags and put it in the bin saved them an absolute fortune, but it wouldn't have been an obvious idea to anybody who isn't trained in effluent and water use. So
That's right.
There's some good quick wins there, I think, for people.
Yeah, there are often quick wins like that, particularly in manufacturing sites. And in very general terms, the things that are most polluting when it comes to trade effluent are sugar and blood.
Okay.
So if you go into, say, somewhere that makes confectionery, there's a lot of sugar in confectionery. You might have icing sugar or granular sugar on the floor. That is highly pollutant stuff. So if you're washing that off the floor into the drain, you're increasing the volume, but you're also producing a very concentrated effluent, which will cause you problems. If you work in the meat processing industry or any sort of abattoir or slaughterhouse, a lot of the byproducts from that are highly, highly contaminating. A lot of it does end up in the drain, but it can cause you problems. And just scraping that off the floor can save huge problems. One problem a number of meat processing sites have had that I've been at is basically the waste meat, the offal that goes down the drain, can then interfere with the water company's pumps and valves further downstream in the sewage system, which can cause them to become tangled up and causes pumps to trip. So somebody has to go and fix it, and that's a cost for the water company. So removing the stuff at source has huge benefits. One last example I would give is a company I dealt with some years ago who made pre-packed salads, who their hygiene crews used to come in and clean down their processing equipment in the evening, and they ended up chasing peas around the floor with a pressure washer, which cost them huge amounts of money. And also the pressure washers were causing a lot of splashing up on the walls. So they actually had to have two hygiene crews, one that came in and cleaned the equipment and one that came in and cleaned the walls. And simply by sweeping the floors and using lower pressure water, they actually managed to get about 20 minutes a day worth of extra actual manufacturing time out of their facility. For a site that runs 364 days a year, 20 minutes a day was actually quite significant. And that came about just by, they were still getting the same degree of cleanliness and hygiene and sanitization, but just in a quicker period of time.
Brilliant. We haven't got any further questions, so I guess we'll wrap it up from there. Once again, thank you very much for joining us. We really appreciate you spending time with us. Hopefully you've got some good bits of learning and some key takeaways. This will be up again. Obviously, we'll get this up on our website and so people can watch it back again. If you've got any further questions or you're interested in having an options report carried out, you can drop us a message through the website or our email address tws@nwl.co.uk. Other than that, I'll just say thank you very much, and we shall say goodbye.